Pressurisation. Pressurisation is necessary to meet the physiological needs of the human body when an aircraft operates at very high altitude. A pressurised cabin means that the aircraft is capable of maintaining cabin pressure at a level higher than ambient. Note that the oxygen content in the cabin does not change. In such cases, the cabin pressure is expressed as an altitude, which is referred to as cabin altitude. The requirements. Components must be duplicated and operate so that at a maximum airflow the system will automatically limit the maximum allowed pressure differential to the design value. If the aircraft is climbing at maximum rate of climb, the maximum differential pressure value may be exceeded by 0.25 psi. The maximum negative pressure differential is 0.5 psi. It should be possible to maintain maximum pressure differential if one half of the air conditioning system fails. It must be possible to rapidly reduce cabin pressure differential to zero by means of manual control. There must be a manual and automatic device for controlling cabin pressure and rate of change of cabin pressure. There should be indications of cabin altitude, differential pressure, and maximum allowed differential pressure. Maximum cabin rate of change of 1800 feet per minute, but most comfortable rate is 300 to 500 feet per minute. If cabin altitude exceeds 10,000 feet, an intermittent aural warning and red failure light will operate. Under normal conditions, cabin altitude should not exceed 8,000 feet, according to Certification Specifications 25. Cabin vertical speed is the rate at which cabin pressure is being changed. Differential pressure is the difference in the pressure between the inside of the cabin and ambient pressure outside. For a jet aircraft, this is typically 7 to 9 psi. For a propeller aircraft, this is typically 5.8 psi. As the aircraft reaches an altitude where the maximum cabin differential pressure is reached, any further climb by the aircraft results in the cabin altitude climbing as well. If cabin altitude has already been reached, the maximum operating altitude of the aircraft will be limited by the maximum differential pressure value. The fuselage has fore and aft pressure bulkheads. Areas not usually pressurised are the nose cone, tail cone and undercarriage bays. Cabin pressure is controlled by delivering a more or less constant mass flow of air into the cabin and controlling the outflow. The main components of the pressurised system in the cabin include a manual outflow valve, safety valves, inward relief valves, and cabin pressure controllers and outflow valves. The outflow valves. These are the means by which cabin height and rate of change are controlled. At a constant cabin altitude, the outflow valves are partially open in order to control the rate at which airflow leaves the cabin. Safety valves. Two safety valves which vent outwards automatically limit the positive pressure differential. They operate at 0.25 to 0.5 psi above normal maximum differential. Inward relief valves, also referred to as negative pressure relief valves, prevent a negative pressure differential which might damage the structure and operate at minus 0.5 psi. The dump valve. This is a large valve which allows a fairly rapid but safe rate of cabin depressurization in an emergency. It's attached to the squat switch so that it is automatically fully opened when the aircraft is on the ground and ensures that the aircraft cannot be inadvertently pressurized on the ground. The pressure controller. This is the main component for controlling the pressurization system. It typically operates in auto, standby or manual mode. In auto mode, its purpose is to control cabin altitude, control cabin altitude rate of change, and limit differential pressure. During a normal pressurized climb after takeoff, the controller ensures that cabin pressure decreases at a slower rate than atmospheric pressure. The cabin is therefore pressurized. Note, if cabin altitude rises when the aircraft is in level flight, the cabin differential pressure decreases, i.e. cabin altitude is getting closer to the aircraft altitude. In manually operated systems, the cabin altitude rate of change is controlled by a rate of change selector. The ditching control valve closes the outflow valves. This graph shows aeroplane pressure altitude versus cabin altitude for various differential pressures. For example, for a differential pressure of 8.6, the aeroplane pressure altitude can be 35,000 feet and the cabin pressure will be approximately 5,000 feet.